All right, folks, in this video, you're going to practice translating between words and symbols. So we're going to do an example of using predicates and quantifiers. We're going to use as our domain the set of all songs, and we're going to define these predicates. S of x will be x is sad. So x would be an element of this domain, meaning x is a song. So S of x means x is a sad song. F of x means x is fast. So we have a fast song. And I know that these are a little bit subjective and relative, but that doesn't really matter for the purpose of this example. So what we're going to do is translate back and forth. We're going to have a column of verbal statements on the left and a column of symbolic statements on the right, and you can see I've left blanks. So I want you to translate there is a fast sad song. I want you to translate that into a symbolic statement using quantifiers and predicates. Probably one quantifier and some predicates that may potentially involve operations. Here is an example of that, a symbolic statement. Figure out what that means and try to express that as a verbal sentence. Okay, go ahead and write that out. Translate. I want you to pause the video and try this on your own. And I'm going to hope that you paused the video and have done this on your own. Now I'm going to go over the answers. So there's a fast, sad song. This is there exists. There exists X. There exists a song that is fast and sad. That's what this is saying, right? There's a fast, sad song. So what I'm going to say is there exists X for which F of X, X is fast, and S of X, X is sad. There we go. There exists X, F of X, and S of X. There's a song that is fast and sad. There we go. So that's how you can translate that into symbols. This one, second one. Now we have symbols. Let's read this and see what it's saying. For all X, so for all songs, it's an implication. Here's an arrow. So if X is fast, then not S of X. This is saying X is not sad. So we could say it like this. For all songs, if it's a fast song, then it's not a sad song. I think I'm going to phrase it a little bit differently for my answer. I'm going to kind of rephrase that in a way that is a little bit more natural. I'm going to say all songs that are fast are not sad. All songs, if they are fast, then they are not sad. So all songs that are fast are not sad. Okay? If they are fast, then they are not sad. That's the same thing. Okay? I didn't even use an if-then in here. I didn't use an if. I didn't use a when. I didn't use any of that. But these are still equivalent to one another. All songs that are fast are not sad. If they are fast, then they're not sad. I'm kind of making a big deal about that because you're used to seeing implication statements expressed with if, then, or when, or only if, or those kind of things. Not necessarily. All right. So here's another one. No song is both fast and sad. Well, this is a bit tricky. What does it mean to say no song? Well, it means that none of the songs are both fast and sad. Is that more of a existential statement or more of a universal statement? To me, it's because it's kind of possible to represent it one way or the other, due to De Morgan's laws, actually. The De Morgan's laws allow us to represent things either with a for all or there exists, because you can always kind of translate back and forth by sort of factoring out or pulling out a negative, right? But to me, it seems more natural that this is more of a universal statement. No song is both fast and sad. That seems to apply universally. It's like we're saying something, we're making a claim about all songs. So I'm going to represent mine as a for all X. So what am I saying about all songs? I'm saying that they are not both fast and sad. In other words, I'm saying it's not the case, so it's negation of F of X and S of X, right? It's not the case that a song X could be both fast and sad. So there is one way to express that. Okay, so now you might have done it in a different way. In particular, you could have used Morgan's laws for and to, like, say not f of x or not s of x, and then you could even use the conditional disjunction to actually convert that into an implication, which, if you do, you may discover these statements are actually logically equivalent to one another. So, numbers 2 and 3 here are actually the same, logically. They're expressed a little differently, like these symbolic statements are a little different and these verbal statements are a little different. I would say these are closer in meaning to one another and these are closer in meaning to one another than either the diagonals are, but they are logically equivalent no matter what. Let's move to our final example here. This one is, I think, the most interesting. There exists x such that if x is sad, then x is fast. Okay, so it's sort of like saying there's at least one song that if it is sad, then it is fast. Well, what does that even mean? If it is sad, then it is fast? What if it's not sad? Let's consider a song. Let's call it a song Y that is not sad. So that would mean S of Y is false. Then S of Y implies F of Y is actually true vacuously, right? Like if S of Y is false, we have false implies something, F of Y. And so since we're talking about a song that is not sad, it actually satisfies this implication vacuously, and we can't make any conclusion about whether or not that song is fast based on this. So this isn't saying very much of anything, right? Because, all it's saying is there exists X, at least one song that satisfies this. That song could be a sad song, and if that song that satisfies this is a sad song, then this would be claiming that it is also that it is a fast song. But there could also exist a song that is not sad, and that song would satisfy this vacuously. And so it's kind of hard to say that this is saying anything. Not much useful. You could say that it's maybe saying if all songs are sad, then one of them is fast. Or it could be the case that there are songs that aren't sad. It's not much of anything. I would say that this is essentially a vacuous statement. It doesn't really have much content to it. And the whole reason it's vacuous is because we're pairing there exists X quantifier with a implication statement. And when you do that, you open yourself up to satisfying this with an element by making it vacuously true, and therefore sort of removing any useful information from it, right? Because you can't make any conclusion about the conclusion of this implication over here. You can't make any deduction about whether f of x is true or false for that one x that must exist. So I just generally recommend never using implication inside of a existentially quantified statement. I hope these examples have been useful and helpful. Next, we're going to learn about what happens when you have more than one variable and you have to have more than one quantifier to deal with them.